So welcome to my 9th video of KTU Advanced Manufacturing Technology question paper solutions. So this is September 2020 question paper, and the question is question number 2A. What are the different motion control systems in NC machine? Explain with figures. So different motion control systems in numerical control machine and explain with figures. Okay, so marks 5 marks. Okay, so this is the question. What are the different motion control systems in NC machine? Explained with figures. So in order to accomplish the machining process, the cutting tool and the workpiece must be moved relative to each other. So in order to accomplish the machining process, the cutting tool as well as the workpiece must be moved relative to each other. So in numerical control, there are three basic types of motion. So the three basic types of motions are PTP motion, straight cut motion, and a contouring motion. Point to point motion, straight cut motion, and a contouring motion. So these are the three motion control systems, different motion control systems. What are the different motion control systems in NC machine? That is PTP, then straight cut and contouring. PTP systems represent the lowest level of motion control between the tool and the workpiece. Contouring represents the highest level of control. So PTP is the PTP, point to point, is the represent the lowest of motion control between the tool and workpiece, whereas this contouring represents the highest level of the control. So once again, PTP, then straight cut positioning control, and contouring, continuous path system. So PTP is also sometimes called a positioning system. In PTP, the objective of the machine control tool control system is to move the cutting tool to a predefined location. So in PTP, the objective is the machine tool control system is to move the cutting tool to a predefined location. The principal function of the PTP is to position the tool from one point to another within the coordinate system. The positioning may be linear in the XY plane or linear and rotary if the machine has a rotary table. Each tool axis is controlled independently, therefore the programmed motion always in rapid traverse. Once the tool reaches the desired location, the machining operation is performed at that position. Example, drilling operation. Drilling. So drilling is an example of PTP. Once the tool reaches the desired location, the machining operation is performed at that position. Machining can only take place after positioning is completed. Okay, so in between there is no machining. That is the specialty of PTP. So NC drill process are a good example of PTP system. The spindle must first be positioned at a particular location on the workpiece. This is done under PTP control. Then the drilling of the hole is performed at the location and so forth. Since no cutting is performed between holes, so here you can see a figure. I will maximize it. Yeah. So since no cutting, so here this is the starting point. This is the starting point. So this is the starting point. Then this is the first hole. Then this is the second hole, and this is the third hole. Here you can see this is the tool path. Operation performed at each point location. Okay. So tool moves from this point to this point. Then machining operation completed. Then move to the next point. Machining operation. Then move to the next point. Machining operation. Like that. So in between there is no cutting. There is no cutting is performed between holes. There is no need for controlling the relative motion of the tool and the workpiece between the hole locations. So figure illustrates the PTP type of the control system. Then next is the so positioning systems are the simplest machine tool control systems and are therefore the least expensive of the three types. For certain processes such as drilling operation, tapping, riveting, spot welding, PTP is perfectly suited to the task and any high level of control would be unnecessary. Then next is the straight cut control systems. So in straight cut control systems, these are capable of moving the cutting tool parallel to one of the major axes at a controlled rate suitable for machining. So it is therefore appropriate for performing milling operations to fabricate workpieces of rectangular configuration. So here you can see the configuration of the workpiece, rectangular configuration workpiece. Most of the straight cut systems has fitted manually adjustable feed control. This feed control is shared by all the programmable axes of the NC machine. Because of this shared feed control feature, the system can also perform milling operation at 45 degrees to the primary axis of the machine. So an example of straight cut operation is shown in figure. An NC machine capable of straight cut movement is also capable of PTP movements. So a numerical control machine that is capable of this straight cut movements is also capable of the PTP movements. So here in this figure, this is the straight cut system. So this is the starting point and this is the cutting tool path. So this is the tool path. So here the tool path operations performed during tool motion either parallel to x-axis or parallel to y-axis. Okay, so that is the straight cut. That means straight cut movement. That is the straight cut system, NC system. That is the second type. And the third one, that is the contouring. Contouring is the most complex, the most flexible, and the most expensive. The least expensive is the PTP system, and the most expensive is the contouring system of machine tool control. This is capable of performing both the PTP and straight cut operations. In addition, the distinguishing feature of contouring NC systems is their capacity for simultaneous control of more than one axis movement of the machine tool. That is the simultaneous control of more than one axis movement of the machine tool. The path of the cutter is continuously controlled to generate the desired geometry of the workpiece. Contouring system generates continuously controlled tool path by the capability of computing the points of the path, that is interpolating. For this reason, contouring systems are also called continuous path NC systems. All NC contouring systems have the ability to perform linear and circular or parabolic interpolation features which are recorded in the NC computer proprietary code. Figure illustrates the versatility of continuous path NC. Milling and turning operations are common examples of the use of contouring control. Milling operation and turning operations are the common examples. So here this is not a straight cut, this is actually contouring. So this is not straight cut, this is contouring. This is contouring cut NC system. Okay, so here you can see in this, here you can see circular interpolation, then straight cut more, circular interpolation. So everything is there. That is the contouring NC system. That is the most complicated. So ability to perform linear and circular or parabolic interpolation features. Okay, so once again, the question is like this: explain what are the different motion control systems. So the different motion control systems are three types. The three types are PTP, least expensive, then straight cut, and the contouring. Okay, contouring. This is the most expensive. PTP, straight cut, and contouring. Then explain with the figures. So you have to explain with the figures, and here you can see 5 marks. Okay, so first you have to draw this figure. This is the PTP system figure. Then after that you have to draw this straight cut system figure. Then finally you have to draw this contouring continuous path NC system. Then explain. Okay, so PTP means point to point. PTP means point to point. There is no cutting performed between the holes. Then straight cut means operations performed during the tool motion parallel to x-axis or y-axis, and contouring means the complicated motion, the combination of PTP as well as the straight cut motion. So that is the three types of motion control systems, used in NC machine. Explain with the figures. Thank you.